Hello, hello. Hello, hello. What's going on? Okay. Right, well. We're just setting things up. Things up. Okay, well, it looks like things are happening here, and we are actually live, which is interesting. So yeah, take a little time. Okay. Yeah, I might need my glasses on for this. So we're going to start at 7 o'clock. That's the thing. But feel free to contact me now if you want. Now this is evolving. I will get better at managing things and doing things. So yeah, and we're on the little black one there. So testing. There we go. All right. Yeah, we're working. We're going. Okay. So we're going for a 7 o'clock start. So yeah, I think everything's set up and ready to go. yeah, this is just the intro. So the show will start at 7, and yeah. So let's see what we can do. Yeah. Okay. Maurieo. Maths. IRL. There we are. We're going. So, yes, let me know if you've got a particular problem you'd like help with. I'm quite happy to do that. But what I will do in the meantime is just talk a little bit about things, topics, and what have you that I think are particularly relevant here. So I've got all sorts of things that I can access, and well, I'll probably be talking to myself for the first one, but anyway, let's see what happens. So here we are, 6:52. We're in the green room, ready to go with Maurieo Maths IRL. This is number 001. So this is the very first show. Okay, just so you know. And we've got all sorts of little bits and pieces that we can do here. So we'll just see. I'm going to go for, well, probably go for half an hour or so and then stop, and then I'll do another one sometime down the track. Feel free to contact me on my email. Probably best if I type that in. So we'll put that on the keyboard. There we go. So oops, not quite right. Probably better to do it with the S Pen. Here. So MAURIEO, Maurieo, NZ1, and yes, we're at, where's the at? Oh my God. Oh, there it is. At gmail.com. So that's where you can that's what it was there, MaurieoNZ at gmail.com. That's my address. So you could send me problems or whatever you want. We've got the chat here. So yeah, that's the whole idea of it. I can, there we go. I can do all sorts of little things regarding maths. So I'm trying to be, my purpose is to be helpful and sort of find out really what people want. The channel will evolve over time, so, but we haven't started yet. All right. Okay, we haven't got an intro sorted at this point, but yeah. So yeah, just click over. The show's going to start in roughly. I wonder, we might be able to edit We might be able to edit the live a little bit out at the beginning. We'll see. But by all accounts, it looks like it's working, and we've got a writing pad there, and yeah, we're about to get underway. Yeah, okay. There it is. Number one. I might have been a bit presumptuous there in there. So yes. Okay. And we'll start at 7. We'll go through to 7:30 unless we're in the middle of something, and yeah, who knows? Who knows what's going on? Anyway, let's see what happens. I'm here with my cup of English breakfast tea and a polka dot cup. I have other channels and presences that I'm on the internet. However, I want to keep this channel fairly wholesome. So you view my other channels at your own risk. Yeah. All right, I'm venturing into OBS software by changing over to this channel here. It's going to be a little bit interesting. So yeah, we'll have to see what's happening. But yeah, that's how it goes, I guess. What do we got? Okay, 2 minutes, and then we're off. All right, we're off. This is episode 1 of Maurieo Maths IRL. So this is an online maths forum, if you like, where I can solve your problems, or try to solve your problems, or help you solve your problems in mathematics. So let's get underway. Want to keep it simple, hopefully. We may get complex. I may get confused and have to come back and with a better answer, but we'll always get there in the end. So the first thing I want to look at, I think, is mathematics. When we think of mathematics, we think of the numbers. So it's, numbers generally. Oh, that was, we wanted to be in black, really. Numbers. Oops, here we go. Yep, numbers. So it's about the numbers. Now, there's a lot of numbers. However, every number has some sort of something about it. Some have more than others and mean different things and have different names. There's different types of numbers. And whilst, this might not seem that important, it is helpful in the process because knowing the numbers and their properties and some of the things about them can help us. We think, well, okay, that's a prime number, or that's a so-and-so number. So the very first number is the number 1, and it's like so. So there it is there. Now you might think, well, okay, that's one thing. What do we know about it? Well, the thing to do here, of course, is what we need to do is have a look at Google. Just go straight to the old Google and see what we can come up with there in terms of the number 1. So I'll just go there and I'm just going to put in 1. I've done it previously, and there's what I come up. 1 News. Videos about 1. But let's see what's happening. What is meant by 1? So we probably need to have a little bit here about tell me about the number 1. There we go, and we can see there's lots of other numbers there. So there we go. A little bit of information about it. Now we can't see all of that because we need to go back to maths here, and we need to go turn that one off and turn that one on. And there we are. You can see what I can see now, which is always very helpful. So there it is. The number 1 is the first positive integer. Integer. What's an integer? It's a type of number. So there's all this information there in it, and a fundamental building block in mathematics. It's the smallest natural number. So we've got integers, natural numbers, and is neither prime nor composite. Okay, so what? Well, these all have meanings and they're all part of the context of mathematics. So in mathematics, 1 is a multiplicative identity, meaning any number multiplied by 1 remains unchanged. There we go. Multiply a number by 1, it's unchanged. Well, so what? Well, that's all part of the rich story and the tapestry that is mathematics and the things that we need to do. Meaning any number multiplied by 1 remains unchanged. And symbolically, 1 often represents unity, the beginning, the origin of things. Yes. Here's a more detailed look at some aspects of the number 1. The number 1 symbolized unity and the origin of all things. Since all other numbers can be created from 1 by adding enough copies of it, for example, 7 equals 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Unless I've missed one out, in which case it's either 6 or 8. The number, not surprisingly, the number 1 is generally treated as a symbol of unity. So, yes, that's the number 1. Now, that's quite intriguing, you know. And then what about, let's have a look at 0. Now, 0 wasn't actually, the concept of 0 took a little while to develop, I understand. Like everyone could say, well, there's one of those over there, but the idea of 0 or none took a wee bit of time. So tell me about the number 0. And there we go there, searching. The number 0 represents the absence of quantity or magnitude. It serves as a placeholder. So we're getting all this language about mathematics and the number. So it's, you can see it's probably quite important that we, you know, understand these things. And it's the understanding of these things, simple things, they're not tricky, that will help us understand the complexity, well, as mathematics gets more and more complex. So we've got 0 in a place value system, and is the additive identity, meaning adding it to any number doesn't change that number's value. Oh, this is 0. So you add 0 to any number, doesn't change its value. Yeah. So if we think back to 1, multiply anything by 1, doesn't change. Add 0, no change. So they've got that in common. 0 is also considered neither positive nor negative, but it's even. It's even. It's an even number. 0, the even number. Now, that's not something that I had at the top of my tongue or mind, that 0 was even. So, oh, well, that's interesting. It's going to add to my tapestry of understanding of mathematics and numbers and things like that. So, yeah, but it's even, and an integer multiple of any other integer, rational or real number. 0 is also considered neither positive nor negative, but it's even, and an integer multiple of any other integer, rational or real number. I'm not 100% sure what that all means, but key points about 0. Show more. Representing nothing. Okay. Placeholder. So when we say a placeholder, like if we have like 100, which is 1, 0, 0, it's a placeholder. It's holding the 1 in the hundreds place. The zeros are holding it there. If you took away the zeros, it'd slide over to the left, it'd just be 1, not 100. So it's a placeholder. And it's additive identity. So this thing of identity, it's a neutral integer, neither positive nor negative, and is considered a whole number and an integer. The concept of 0 as a number emerged relatively late in history, as I was saying earlier, with early use as a placeholder and later as a number in its own rights. Mathematical properties, 0 is even in an integer, multiple of any other integer. Essential for modern mathematics, 0 is fundamental for concepts like calculus and modern engineering. Okay, and there we go on. So there's numbers. Now, if we tell me, you can now choose any other number, like for instance, all numbers have like different properties. So, and sometimes those properties are in terms of mathematics, maybe, or maybe they're, from the spiritual realm, or, they have various meanings in different cultures and things like that. So, there's quite a lot. People spent quite a lot of time working with numbers. So I'm going to try a number, like if we look at some of the numbers that we use, some of the reasoning behind them is quite interesting. So let's look at the number 24, which is the number of hours in a day. Okay, 24 is a natural number, following 23 and preceding 25. So it is even, composite, and is an abundant number, a practical number, and a congruent number. So it's got all these different properties. We might not know what some of them are. Mathematics, 24 is the factorial of 4. Now, I do know what that means. That means 4 times 3 times 2 times 1. 4 factorial, 24. 4 times 3 is 12, times 2 is 24, times 1, 24. And is divisible by 1, 2, 3, 4, 6, 8, 12, and 24. So, these are the factors, key properties and associations. So here we go. We can show more on this. Mathematics, 24 factorial. It's also the smallest number with exactly 8 divisors. 8 divisors. So if we look there, 1, 2, 3, 4, 5, 6, 7, 8. There are 24 hours in a day. There are 24 elders in the Book of Revelations. Chinese cosmology, significant in the 24 solar terms which design the seasons. 24 on the backgammon board, and numerology. 24 is often associated with balance, creativity, and a blend of artistic and practical skills. So, very good. Fun bars, the fun facts about. So, you can look at all these numbers and they come up, and some of these things are very helpful for our understanding of mathematics. So a number that comes up a lot is my favourite noodle bar, and it's 168 noodle, it's at the Flagstaff Shopping Centre. So I look at the number 168. Now, I just thought, it's 168 noodle bar. But as I was working my way through things, it came about that we could see 168. The number 168 is a natural number. It comes after 167 and before 169. And it's an even, divisible by 2. Even number. Significant in several contexts. It's the number of hours in a week. See, there you go. 168 is 24 times 7. 7 days. And in Chinese culture, it's considered a lucky number. So my noodle shop, 168 noodle, it's a lucky number, and number of hours in a week. And I think these things help. For me, anyway, I find them helpful in my understanding of mathematics, and, it just makes it a little bit more interesting. And sometimes it helps me by recognising numbers. So, like 24, that's a really good number because it's got a lot of factorials. So that can be quite helpful in some situations where you want a number with a lot of factorials, and that is in fact why it was chosen as the number of hours in a day, I think. It was, it was a nice even number that could easily be divided in a good period of time. And then, of course, you get the hour, 24 hours in a day, but then we divide the hour into 60 minutes. And, 60 minutes is, we'll have a look at maybe the number 60 after this. I just threw in my 168 because that interested me. It's divisible by 2. It can be broken down into its prime factors. Now, prime numbers, which, I will be adding these things in, but I thought I'd start off here, as I don't have anyone joining me. If you've got a question, just stop me at any time. But prime numbers are numbers that can be multiplied by themselves or 1. But remember that 1 is not a prime number. I think we said it's not prime. I'll have to look that up. I can never remember that one. So sometimes, yes, some of the stuff you may have to look it up, but it's the thing is that I know that if I'm asked that question, I'll either know it or not. I won't. So if I don't know it, I'll go and look it up. But I'm pretty sure we said it wasn't. Various broken into its prime factors. So it hasn't got 2 by 2 by 2 times 3 times 7, or 2 cubed times 3 times 7. So 2 cubed is 8, I think. 2 cubed is 8. 3 sevens are 21. 21 times 8 is 168. There we go. So that's all. And divisors, these are all numbers, has various divisors, including, so these are all numbers that will divide into it. 1, 2, 3, 4, 5, 3, 4, 6, 7, 8, 12, 14. So all of those go into 168. It's a lucky number in China, has a positive association in Chinese numerology, where it sounds like Yili Fa, fortune all the way. Oh, there we go. And Wikipedia's got something to say about it, Chinese and so on. So let's have a look at the number 60, because I talked about that. What happened there? Let's go back here. I'll go with, have a look at the number 60, because that's another interesting one. So here we go, and we can see pretty much the same thing. 60 is a fascinating and significant number. Various connections, time, measurement, and history. It's notable for being divisible by 1, 2, 3, 4, 5, and 6, making it the smallest number with this property. Okay, it's divisible by all of those, and that's that divisibility that why people use some of these numbers, so that they can, it makes fractional things a little bit easier. Played a crucial role in the development of the sexagesimal base 60 system used by the Sumerians and Babylonians. The number, we use a decimal system. So they used base 60, ours is base 10. The number 60 found in model time and time measurement. 60 seconds in a minute and 60 minutes in an hour. It's also used a lot in division of degrees as well, degrees, minutes and seconds, which are also sort of related to time and rotation around the Earth. So mathematical significance, highly composite number. 60 is a highly composite number. It means it has more factors than any smaller number. It is also a superior highly composite number and a colossally abundant number. Oh, 60. Yeah, go 60. 60 is divisible by, look at that, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Prime factorization, 2 squared times 3 times 5. Yes? And sexagesimal, the ease of dividing by 60 by other numbers likely contributed to the development of the sexagesimal system. Base 60 used by the Sumerians. Time and measurement and angles and finger counting. Some scholars believe the Sumerians used finger joint counting to arrive at the number 60 as the base of counting. With 12 joints on 4 fingers, the thumb free to count. Okay, 12 joints on 4 fingers. Okay, so that's 2 on each. 1, 2, 3, 4, 5, 6. Oh, 12 joints. I call it counting. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 joints they were able to. No, that's just a theory. We'll see other connections. All right, the Napoleonic Code, numerology, elements. And the main belt asteroid is named after the number, and the ASCII code for the less than system symbol is 60. So yeah, there we go. All about 60. So that's a little bit about numbers there, and the sort of not the importance. It doesn't really matter if you don't know all those sort of things about numbers, but I find it helps if you do know those numbers, because they come into play, particularly in the mathematics that we do in schools and things like that, because some of these, they're sort of like a little cheat code, really, because you can see, you can look at certain numbers and certain problems that you're presented with, and you can see a number in there. Say you see the number 4, and you think, well, that's 2 squared. So I wonder if this problem is going to use that property, that it's 2 squared. Or you see the number like 24 and you think, oh, that's got various factors. I wonder, which factors it's going to use and how that's going to affect. So, like when we're trying to do things like quadratic equations and things like that. So, that's what I got. So, I think let's have a look at some of the stuff. Now, all of this is available online, and you can use it using your AI, like your Chat GPT and things like that. They're all there to use. My personal favourite at the moment. It varies from time to time. I've been using Grok, and they're on. It's available on Twitter, X. So give me a brief rundown on prime numbers. So prime numbers. What do we need to know about prime numbers? So prime numbers are natural numbers greater than 1 that are divisible only by 1 in themselves. Okay, so only by 1. So they have no other numbers that divide into them. So, so it's the first few. We've got 2 times 1, that's it. No more. 3 times 1, 5 times 1. 6 is 2 times 3, so it's not a prime number. So we've got 2, 3, 4 is 2 squared. So it's a prime number. It's a square number, what we call a square number. And so, yeah, and then we've got 8 and 9 and then 11 and so on. So the definition, a number p is greater than 1 is prime if its only positive divisors are 1 and itself. Every natural number greater than 1 can be expressed as a unique product of prime numbers. That's the fundamental theorem of arithmetic. Now, natural numbers are the numbers 1, 2, 3, 4, 5, 6. Okay? Yeah, oh, okay, so what? Well, yeah, they're just those numbers. So if you want to talk about decimal numbers like 1.27, see, that's a number. 1.27 is a number. Pi is a number. But they can't be expressed as a product of prime numbers, and those numbers are not natural numbers. They're decimals and things like that. So that's what the difference is there. Primes become less frequent as numbers grow, but there are infinitely many things. Examples: cryptology, number theory, random number generation, testing primality. So great mathematicians have spent a lot of time testing as to whether a number is prime, trying to find the highest prime number they possibly can, or whether a particular number is prime or not. And 2 is the only even prime number. Mersenne primes, like 2 to the power of 31 minus 1, and twin primes, like 11 and 13, are notable. Twin primes. I don't know what twin primes mean, and I'm there, so I'd have to look those up. There's no formula to predict all primes, and their study remains a vibrant field in mathematics. People study prime numbers. Okay, and so there we go. That's just a little bit of an introduction about prime numbers. But what I'm really looking for in this program is I need feedback and engagement from people watching, so that we can, solve actual problems, and then I can maybe, as these little things come up, I can refer to them and we can have a look and investigate and do things like that. So yeah, that's what we're doing now. This is my first one on this, so I'm just learning and trying to teach myself how to do this and make it run smoothly. So things are not going, won't always run smoothly, but we'll get there in the end. So yeah, send me your problems. I will try to solve them. You can send them any way you like. I don't mind how you send them. You can email me at maurionz1@gmail.com. Maybe a comment on a video. There's various ways. I'm also I'm Maurieo on TikTok. I'm on Instagram, YouTube, Facebook, so I'm pretty easy to find. And yeah, hopefully I can be of some help to you. So that's what I'm offering. Let me know. Let me know if you need any help. So I'm going to finish it up there. Good night and good gardening to you all. This has been a Maurieo presentation, recorded live in our lovely little studio in downtown Naruawahia, the Big Smoke in Aotearoa, New Zealand, a place where Kiwis live, in a paradise we like to call God's own country. Good night and good gardening to you all.